Consider a unit circle with center at origin of the coordinate axis where the points A, B, C and D are the intersection points of circumference of circle and coordinate axis. So, the coordinates of points A, B, C and D will be 1, 0, 0, 1, -1, 0 and 0, -1. Let P, A, B be any point on the unit circle with center at the origin such that angle AOP equals x radian. That is, length of arc AP equals x. If angle AOQ equals minus x, then the coordinates of the point Q will be A, minus B. Now, draw a line PQ from point P to Q along the x-axis. Therefore, sine minus x equals minus sine x. Since for every point P, A, B on the unit circle, we have A lying between -1 to 1 and B lying between -1 to 1. We have cos x lying between -1 to 1 and sin x lying between -1 to 1 for all values of x. In the first quadrant, A and B are positive. In second quadrant, A is negative and B is positive. In the third quadrant, A and B are both negative. In fourth quadrant, A is positive and B is negative. Therefore, we can find the signs of all trigonometric functions sin x, cos x, tan x, cosec x, sec x and cot x in different quadrants. In fact, we have the following table. Let us see from the definition of sine and cosine functions, we observe that they are defined for all real numbers. Further, we observe that for each real number x, sin x lies in the range -1 to 1 and cos x also lies in the range -1 to 1. Thus, domain of y equals sin x and y equals cos x is the set of all real numbers, and range is the interval -1 to 1, that is, y lies between -1 and 1. Note that both -1 and 1 are included in the interval. Let us see the domain and range of other trigonometric functions. So we have this table. On the left hand side, we have all the trigonometric functions, which are cosec x, sec x, tan x, and cot x. In the middle, we have their domains, and on the right hand side, we have their range. Now, we will observe the behavior of trigonometric functions in different quadrants in a tabular form. So we have this table in which we have the behavior of sin x, cos x, tan x, cot x, sec x, and cosec x in the first quadrant, in the second quadrant, in the third quadrant, and in the fourth quadrant. Let's see this remark. We can see that the value of sin x repeats after an interval of 2 pi. So we have this on the graph. Observe the curve. The domain is set of all real numbers and the range is -1 to 1, both included. We can see that the value of cos x repeats after an interval of 2 pi. The domain is set of all real numbers and the range is -1 to 1, both included. Let us see the graph of the function y equals tan x. The domain is x such that x belongs to set of real numbers, but x is not equal to 2n plus 1 pi by 2. You can see that at x equals to 2n plus 1 pi by 2, cos x becomes 0. So tan x cannot be defined. That is why we have excluded this from the domain. The range of tan x is set of all real numbers. You can observe the graph. Let us see the graph of the function y equals cot x. The domain is x such that x belongs to set of real numbers and x is not equal to n pi. Note that at x equals to n pi, the value of sin x becomes 0. That is why cot x cannot be defined. Hence, we have excluded this from the domain. The range of cot x is the set of all real numbers. You can observe the graph. The range of sec x is y such that y belongs to the set of real numbers and mod of y is greater than or equal to 1. You can observe the graph. The value of y never becomes equal to any value which lies in the interval -1 to 1. Otherwise, it assumes all the real values. Let us see the graph of the function y equals cosec x. The domain is all the real numbers, but x should not be equal to n pi. Note that at x equals n pi, the value of sin x becomes 0. That is why we have excluded it from the domain. The range of cosec x is set of all y such that y is a subset of real number and modulus of y is greater than or equal to 1. You can observe the graph.